So hello everyone. Today in session number 25, we are going to start with sheet metal. We are going through solid edge sheet metal here. So to start with, I am having some theory. First we will go through some theory and then we are going to go for the commands. So talking about sheet metal is any metal that is in the form of sheets and has thickness in between 0.15 to 6 millimeters. In some cases, the sheet metal thickness also exceed above 6 millimeters. It is not compulsory that they are going to be in 6 millimeter range only. In some cases, they extend up to 10 to 12 mm also. But they start usually from 0.15 mm. So, sheet metal manufacturing is the process of creating sheet metal parts by cutting, bending, and forming. So these are the three operations, that is cutting, bending and forming, usually done. They are having many subtypes also in the operations, but they are specifically used to shape the parts and bring them to sizes required. Sheet metal is a thin, flat form of metal. It is shaped by rolling through industrial hot rolling or cold rolling equipments. You can see here two rollers are being placed and sheet is passed in hot condition through the rollers so as to make them thin and obtain the required thickness. So these are the parts you can see which can be made by sheet metal work. Here are cabinets, brackets, some grid walls, CPU units, electronic equipment covers and etc. All these products can be made by using sheet metal work only. It is very cheap and easy to make manufacturing process. The operations in sheet metal are shearing, punching, perforating, notching, sheet metal cutting, blanking, piercing, slotting and bending. Basically, there are two processes which are used to make flat thin sheets, that are hot rolling and cold rolling process. So here the difference is also important. So in many interviews of mechanical designs, this differentiate is also been asked. Before starting to work in sheet metal, you should have this knowledge also. So here is the bending terminology. In this bending image, it is shown which terms are usually used in sheet metal, such as bend radius, bend axis, bend angle, thickness, what is neutral axis, what is bend line, what is flange length, what is bend allowance, which area is called as bend allowance, which side of the radius is called as bending radius. So the inner side is usually used as bending radius, as well as bending angle. You can see here. So this is the bending angle. Now the materials used for making the sheet metal are, so here the first metal usually used is stainless steel plates. The dimension specification ranges from 0.1 mm thickness to 10 mm thickness. If they are more than 10 mm thickness, then they are known as plates. The standard widths of this sheet which are available in market are 1524 mm, that is 5 feet, maximum to 1219 mm, that is 4 feet common. Length is customizable. If you want to customize the length, you can go for 8 feet also. Second one is cold rolled steel. Material thickness ranges from 0.25 to 3.2 mm. Thickness exceeding 3.2 mm can be customized. Means the usual thickness of cold rolled steel would be 0.25 to 3.2 mm in standard range. The material width of cold rolled steel will be 1524, that is 5 feet, till 1219 mm, that is 4 feet, that is common width. Then the third material which is commonly used is aluminium sheets, having maximum width, that is 5 feet to 4 feet. Fourth one is hot dip galvanized steel plates. So this material is also very commonly used in industry as a sheet metal material. So the material thickness ranges from 0.4 mm to 3.2 mm. Material width here also goes by 5 feet to 4 feet common, and they are also customizable. Then the fifth type that is used in sheet metal work is hot rolled steel, HRS, also known as HRS. Thickness ranges from 1.4 mm to 6 mm. Standard width ranges from 4 feet to maximum width by 5 feet. Standard length that will be around 8 feet. Lastly, copper. It is one of the metal that is usually used for sheet metal work. Here the thickness of copper is usually used very less. So the thickness range will be maximum or minimum 0.3 mm. Standard width would be 2 feet and length would be 5 feet. So these were the metals that I used, that were copper, HRS means hot rolled steel, hot dip galvanized steel, aluminium, cold rolled steel and stainless steel plates. These are the common metals. Other than these metals, some alloys are also used, and some different metals are also used, but they are rare. That's why we have not mentioned them in this list. So the first command we are going to start with sheet metal is this tap flange. So to start with tap flange, it is compulsory for us to make a close sketch. If you are using an open sketch, you cannot use this tap flange. And there is one more rule here, that this tab is only used one time in complete sheet metal part. If once used, you cannot use this second time in complete part here, or else it will not make a flattened sheet. That's why tab is only used for one time. So we'll start with tab, directly select the command, and then we are going to make this sketch. I'll say coincide plane here. And as we said, we need complete close profile. So I'll go for the standard rectangle here. I'll say center rectangle. The length I want here is 220 and the width I want here is 108. After completing this sketch, we are going to go for this option, that is close sketch. As soon as you say close sketch, thickness option will appear here, providing the thickness to the sketch and making it a solid sheet. So here the thickness I'll say 1.5 mm. It will ask you for direction. You can see here this red arrow. If I want to move the thickness upside, I just need to drag the mouse upside. If I drag the mouse downside, the thickness will appear at the downside. So at whatever side you want, you can keep it there. I'll place this thickness at the upper side here. Say finish and cancel. So every sheet metal part which is going to be will start with this command, that is tab. This is also known as base flange. So the next command we are going to see here is flange. It is going to start with edge. That's why it is referred as edge flange also. So we are having these three conditions given, that is material inside, material outside and bend outside. So whenever I click on the edge flange, you can see that green line is appearing and this complete flange is coming inside that green line. You can see here. So we can say that material is inside. The material is coming inside. If I go for this option, that is material outside, then you can see here this thickness is coming outside the material, outside the green line. That is 1.5 thickness we have taken earlier. Third condition is given bend outside. Means this complete bend will come outside the material. So these were the three end conditions. And for height, there are two options given at the lower side, you can see here. That is inside dimension. If I take this inside dimension and click on the flange, you can see the height is coming here. I'll change this value by clicking on it. Just say 50 mm. So this height is coming 50 mm from the top side of this base flange. That is from the upper face of the flange to the upper face of the edge flange. And if I change the end condition while taking the flange, again I'll go for the flange. I'll select the flange command here. Click on this edge flange. And if I go for this height option, that is outside dimension, it will take the dimension from the outer sides. You can see here, this is coming from outer side to the upper side. I'll click this dimension here. I'll say 90 mm. So this is the outside to outside dimension. Earlier, the dimension was coming excluding the thickness. This time the height is coming including the thickness. This is the main difference between these two height options. Say finish here and cancel. I'll delete these flanges here. Now we will see the width options given. For that, again I'll select flange command. Click on this option. You can see these width options. They are not editable. Means they will appear only when we have taken the flange first time. Other than that, we cannot edit these options here. So the first option is complete width. That's why we can see this flange is coming from one end to another end. Second option is given centered flange. So in centered flange, this width of the flange will come symmetric from the center. I'll change the end condition and say material inside. So you can see here, the end condition is being changed and we have taken material inside. Now as I have taken centered flange, you can see here this 36 is divided on the equal sides, both the sides symmetrically. If I change the value and say 50 mm here, this width will appear 50 mm and this height I'll say 70 mm here. You can also see one gap is coming here at both the sides of the centered flange. This gap is nothing but auto relief gap. It is used to relieve the stresses and to avoid the shrinkage of metal while bending. The width and depth of this cutout can be edited here. So for editing the depth and width of this gap, by selecting this option, here you can see, select this option And here, if I want to change the depth, I'll just tick off these options. If I want to change the depth, I'll say 1 mm. You can see the change applied here. I'll change the width also. I'll say 2 mm width. You just need to observe here, say OK, and this width is increased on both the sides. So this was end relief, also known as auto relief, and the width option we have seen here was centered flange, which was having dimension symmetric on both the side from the center. Next option we are going to see here is again flange. Selecting the edge flange again, taking the height here, say material outside, say the width option as at end, and we need to select one end. So the flange will appear from that selected end only. Earlier we have taken centered option, that's why this flange was coming from the center symmetrically. At this time we have selected the option that is at end, so this flange is coming from the end side. Here also at one side you can see the auto relief gap. If I want to change the dimensions of the width, height or angle, we can change here. So I'll say this as 80 mm. I'll change the height here as 60. I'll change the angles also. I'll say 70 degrees here as the angle. And now all the flange profiles are being changed. If I want to edit this profile and add some geometry also here, then we just need to select this option that is profile step. I'll add one corner rectangle here by 2 points and I'll trim this option here. Say close sketch and finish. You can see this width is completely edited here. And now I want to edit the auto relief gap here. I want to put some depth also here for this relief gap. So I'll say flange, say edit definition, go for these options, just put off this option and you can edit the values here. I'll say depth as 1 mm only. You can see the change here now. This depth is increased by 1 mm. Say finish. This may be asked in some sheet metal interviews why this auto relief has been provided. The reason behind it is to relieve the stresses as well as to avoid the shrinkage of the metal. Again we are going to select flange option and we will see the next width option here. For that I'll select the edge and here we have the option from both ends. So it will appear like center flange only, like this flange only, but only thing is that the dimensions are controlled from the ends, not from the center. So here the dimensions were coming symmetric from the center, but this time the dimensions are not coming symmetric. We can change the values here. We can increase or decrease the values at the ends here. So if I want to change the value and say as 25 and I will say this value as 40, I can change the values. Say finish and cancel. So this is the main difference between these two flanges, that is center flange and flange from both the sides. I'll select here the flange option again, click on the option and lastly we have from the end. So now at whatever end I'll click here, this flange will appear having two dimension, one from the end and one this width option. So I'll change these values also here. I'll say 40 mm and here I'll say 90 mm. Say finish and cancel. Again if I want to edit the profile of the shape, select the flange, go for this option edit definition, go for profile step option and you can edit the profile. This time I'll add the circle here. I'll trim the intersections and say close sketch. So you can see here the flange profile is being edited here. So we can edit the flange profiles also. I can put the extra offset value also here. For that I need to select the flange, say edit definition and we have the option as offset from step. So here you can put the offset from step dimension. Click on the option and say 9 mm. Say right click and finish. So here you can see this flange has been updated here. There is one offset from the edge. If I want this offset inner sides, I'll say edit definition again and I'll say this value as -9. This offset will appear at the inner sides. I'll change the width option for the end relief. I'll increase this width. I'll say 4 mm here. So this was flange command with multiple options. So the next command we are going to see here is multi-edge flange. Earlier we have seen the flange command in which we can only draw one flange at a time. In multi-edges, you can select multiple edges at one time to draw the flanges. So this is the main difference between flange and multi-edge flange. Flange option is having multiple options for editing, but if we make flanges by using multi-edge, then the options for editing are very less. So we'll start with the multi-edge. I'm going to delete the earlier flanges. And then we are going to go for multi-edge flange. Here I'll select the edge, and if I want to select multiple edges, I will go for the opposite edge also and say OK. Now as I have selected both the top edges, the flanges are coming at the top side. If I want to change the direction, we just need to flip the mouse. The flange direction will come at the lower side. I'll escape, and suppose if I select the command again, and this time I am selecting the lower flange of this side, that is right side, and the upper flange of the left side. So the direction of selections is lower flange at the right side and upper edge at the left side. So I'll say OK. You can see here these directions will come at the opposite sides. So it is up to selection of the edges at what side I want to extrude the flanges. Say escape. Again we'll go for the option that is multi-edge flange. I'll select all the four flanges at one time only, all the upper edges. Say OK. And now we need to give up the height. So I'll say 50 mm here. So now the multiple flanges are appearing with having height of 50 mm. If I want to change the angle, just click on the angle option and I'll change the angle to 100 degrees. If I want to change the height, select the value and say 60. Whatever height you want, you can update there. I'll again change the angle to 90 degrees here. Say finish and cancel. Now we have taken the thickness as 1.5. So we require the bending radius to come as 1.5 only. But if I select the feature and say edit definition and go in these options, here you will see this bending radius is coming by default as 1 mm only. It is by default by solid edge only that the radius is set to 1 mm. If I want to update the bending radius, we just need to click off this option and here you can put the required value you want. So the minimum bending radius to be taken for sheet metal should be equal to thickness or more than thickness. We cannot go for the value lesser than the thickness value. So here we have taken the thickness as 1.5. I will say bending radius also as 1.5 only. So the bending radius are been updated here. Now suppose if I want to make this part as flatten, which is compulsory for us to make the part flatten. For that we'll go for tools and here we have the option flatten. It will ask you to select the upward flat face. So I'll say this face here. Next it will ask you to select any edge parallel to X direction. So I can select any edge related to the selected face. So I'll click this edge here that is parallel to X. And you can see here this flatten or development length of this part is coming in. So the length is coming 334.27 and the width is coming 222.27. If I again want to reorder it or else if I again want to unflatten it, we can go on this option at the left side, top left side, that is ordered. Just click on this option and all the flanges are back to its positions now. Now if I want to edit the width options of the multi-edge flange, as compared to flange option there were multiple width options, but in multiple edge flange there are only two options. We'll see that one. For that I'm going to go here. So to edit the width options, I'll select and say edit definition here. Go for this perimeter step and here we have width options. I'll say centered width. So now you can see all the flanges are coming from the center with symmetric dimensions on both the sides. If I update this width, suppose I'll say 36 instead of 36 I want as 56 here. So all the four widths will be updated at one time only as we have made all the flanges together. Next for the height, you can see here the height is coming as 60 mm. But this height is coming 60 mm from the upper face of the tab till the upper face of the flange. So if I want to edit this option and include the thickness also in height, just go to perimeter step, say measurement point option. First option will stand for excluding the thickness and second option will stand for including the thickness in the height. So in this way you can exclude or include the thicknesses in the height. Next, the material condition. It is coming inside, you can see the line at the flange and this flange is coming within the line. If I say material outside, then this thickness will come outside the line. You can see this line here, this edge and this thickness is coming outside. If I change the option and go for the last one, that is bend outside, this complete bend will come outside the line. So these were the four end conditions. I'll again update the material side here. I'll say material inside only and keep the side at the upper sides only. Next option given here is offset step. For that, I'll finish this. I'll delete this multi-edge. Again, go for multi-edge option. Select the two edges this time. Say OK. And after making these flanges, here I can say I want these two flanges to be offsetted from the edges. For that, select parameter step and go for this offset option. And here you can offset them. You can see a distance with arrows coming from the line. I'll set 10 mm. So now these flanges will be offsetted from the edges by 10 mm distance, outside or inside, whatever direction I want. So I'll add 10 mm here and say finish. If you click on this option, that is dynamic edit, you can see here this sketch was made in this way, but the flanges are coming 10 mm offset from the sketches. So this was offset option, and now we have completed the multi-edge option also here.